got a set of slides in here somewhere. Yeah, I got the other two on. I took a guess that it worked.
Can everybody in the back here? That's out, Mike.
Yeah, can you guys in the back here?
Yeah.
Great. You guys in the front going deaf? Okay, good. Go slower than that. Welcome to data visualization. Thank you for coming. We are in a new space here today with BiteCubed. Wanted to thank Danielle Bolo and Rebecca Bilbro for letting us know about this and bringing this opportunity to us. If you ever see them, give them a big thanks for routing this to us. And today we're featuring Ryan Boyd. There's Ryan right here for a very cool talk about visualizing the Panama Papers, which I've read a lot about it, but I'm looking forward to this presentation. And I didn't put Carla on here. I'm sorry. Carla, are you here? Where? Stand up, Carla. Come on. This is Carla. She's one of our new organizers. If you want to know, we're always looking for new mini hacks or new presenters. So if you know somebody who is having some challenges visualizing their data, we organize some mini hacks, or we do things like this. There's also a conference that DC2 is putting together in October. Any of those things, find myself, find Crazy Tony here, find Carla, Kareem, and Sarah are not here today. Who here knows about Data Community DC? I love it, keeps getting more all the time. So we've got some key groups here, women data scientists, data viz, statistical programming, data science DC. We have an extended family. I'm actually missing a couple on here. So I think we have a dozen now. We just added 2 more. So we generally offer services to people who are trying to organize these things, like finding spaces and getting sponsors and stuff like that. I think I already gave a shout out, but anything you wanted to say, Kareem?
Yeah.
Okay. So anybody here from Social Data DC? I don't think so, right? Okay. And so we also partner with companies. I know people here, sometimes you're looking for jobs, sometimes you're looking for consulting, sometimes you just want to ask a few questions, mentor-mentee type thing. General Influence, GI, that's my company. ATA is out of Tyson's. Data Society is out of Chinatown. Krish Corp is Uptown. Deep Learning Analytics does DARPA work. These are the top data science firms in the area that offer themselves to this community. So let me know if your company is interested in getting involved. And in general, if you want to get involved with this community in any way, just send an email to agents@datacommunitydc.org. All of this is being recorded. It's going to go on our YouTube channel, so just look for Data Community on YouTube. And who here signed up on the Google form? I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There were 20 overall. I developed some of the code for developing this association matrix. This takes your interests and finds out what the intersection is between you and other people that signed up. The idea is to help you meet other people that have similar interests at the event. You should have gotten an email with a list of people. In time, Peter, you want to stand up, Peter? Peter and I are developing an app which will make this a lot more interactive, save your data so you don't have to be filling out the same darn form every time. But it takes time. We've got a couple good sponsors. I always turn this over to Crazy Tony.
All right. We have so many sponsors, so many great sponsors, so many friends. All right, our first friend is Bruce Allen. They're great. They're amazing. Believe me when I tell you they're going to make data great again. You like machine learning? You like data analytics? You like defense, government contracting? Bruce Allen, they've got it. O'Reilly, they're great. I've never met a book in my life, but they're so great. Like, they can write the art of the data deal, and it'll be winning. Because all you do with data, you win. And then we got our educational sponsors. District Data Labs, they do data training, so you can be the winner of data. It's so much data, so much winning, you'll be so sick of data. And then we have statistics.com, because just because you win them, just because you lose the popular election doesn't mean you're not a winner. It's so great. And the Data Society, because they're great, and it's so great because data is everywhere, and we're going to make data great again. And educational sponsors, type that link in, get 50% off, huge discount, big league deals from statistics.com. And our MC Escher sponsor tonight is Byte Cube. They do great stuff. You didn't have to walk up an MC Escher staircase to get here, so everybody give them a round of applause for the space. So good. Announcements. Starting with you here.
Oh, okay.
And she's great. She's so wonderful. She's Neo4j.
Hi, I'm great. Actually, I'm Corinne. I'm the community manager with Neo4j. Thank you guys all for coming today. Can you hear me? Yeah. Too close? Too far? Is this okay? Okay. So I did want to talk to you guys about a conference that we're hosting in New York this coming October, towards the end of October. It's Graph Connect. I don't know if you guys have heard of Graph Connect before. It's hosted twice a year, once in Europe, and then in the past couple years it's been hosted in California, but this time it's coming to New York. So we're really excited because it's right down the street. Sort of down the street. Up the street. And we're offering a 50% discount for tickets purchased tonight. We're using this promotional code. So feel free, if you're interested, to go online and purchase your tickets tonight. And you can come to Graph Connect. There's a lot that goes on there. It's a 2-day event. There's like hackathons and training, and we have graph clinics so we can help you with your data modeling. And it's all over the board in terms of technical talks and things that are more like business oriented and how to use graph databases for optimizing solutions. Yeah, and that's the announcement for this.
Right, I want to give other people a chance.
Okay.
Anybody else? Jobs, meetups that are happening, questions that you have, general life challenges.
Does anybody have any general life challenges that they want to talk about? Oh, sure. I believe it's like a talk show.
I didn't really want to talk about it, but I have a lot of life challenges.
So, if there's any personal counselors, leave me afterwards, and I'll tell you all of my life challenges. Thank you.
And if anybody has any community challenges.
I think I saw another hand raised, right? No?
Somebody else? Share
if you're looking for a job right now, if you have jobs, any announcement.
Does anybody have anything that they want to talk about?
I'll talk about something.
There we go. Well, we already got
I'm Jason Zagalski. I'm with Neo4j. I'm the Federal Account Manager. And if any of you are interested in chatting tonight, I'll be here. There's lots of goodies down there. There's O'Reilly's one of the sponsors. We have a book called Graph Databases that our founder and chief scientist wrote at the request of the O'Reilly folks. There's a card over there. You can download a free copy of the Graph Databases book. The other thing I wanted to mention is June 15th. There's a meetup with the Graph Databases meetup group, and it's in Roslyn. And Preston from Caliber is going to be talking about enterprise security, including Kerberos and is there one other thing? Kerberos and Active Directory on June 15th at the Graph Database meetup. So check it out.
Thank you. And most important part is that after all of this, you can't think anymore. You need beer, and there's beer right up the street. This is us right here, and we just go up the street, and then there's beer at Highline. So that's data drinks afterwards. And I'll ask Corinne to give the introduction to our speaker today.
So I'm going to give Ryan a formal introduction because he's very, very special. So the speaker tonight is Ryan Boyd. He is head of developer relations with Neo4j, and it's kind of a mix between engineering and community. Formerly, prior to Neo4j, he was with Google working on their cloud technologies for about 8 years. And he's a pretty awesome guy. We love him, and we're really excited to hear his talk. So, please give a round of applause to Ryan Boyd.
Thanks, Kareem. Okay. So I'm wearing my Neo4j shirt. This is about Neo4j in part, but it's really about the angle of Neo4j and graph databases that we like to use to make the world a better place. And so, we say that, Neo4j is for a wide variety of different use cases. We can get to that later. But Neo4j for good is an important part of our mission. And so NASA uses us to get to Mars faster, to make without incidents. They use us to basically discover what has happened in previous accidents and all through the missions to space and to prevent those. We have folks using us to understand cancer. We have folks using us to understand other medical diseases and such. And tonight we're here to talk about using Neo4j and graph databases to discover corruption. So this is about the Panama Papers. And how many people, before they saw this session, were familiar with the Panama Papers? Actually, that's a good number. You go elsewhere in the US, it's not quite as high. I guess DC hears about these things a little bit more. And if you go in Europe, everyone has heard about it because a lot of the effects of this investigation were present in Europe. But so we're talking about Neo4j. My Twitter handle is RyGuyRG, and I'm not used to actually having formal introductions, so she said some of this, but my email address is ryan@ryguy.com or ryan@neo4j.com. Either of those will get to me. Feel free to reach out to me if you have any questions from tonight or any questions overall about the stuff I talk about graph databases. Hopefully not about OAuth. I actually have an O'Reilly book too, which is about OAuth. But those questions tend to be a little bit more difficult to answer. But anyway, if you have any questions, reach out. So I'm going to show you 2 very short videos here, and I'm going to pray that this gets through to this TV. So let us fix volume. Do this. Is that picking up?
A little bit.
Make this as a view. Do you need sound? It's not. This is going to actually explain a little bit about what these offshore bank accounts are used for in a really funny way. And this is courteous of Flex.
So let's say you save your quarters in a piggy bank, keep it on a shelf in your room, but your mom keeps checking up on how much you're putting in and how much you're taking. You don't like that, so what you need is a second piggy bank to keep somewhere else. Your friend Johnny's mom is busy. She doesn't have time to check on piggy banks. You can bring a spare bank over there, and money can come and go whenever you want. And then maybe Jenny's mom isn't really too busy. Maybe she's just lazy. Maybe she's deliberately telling the whole neighborhood for a small fee she'll keep their piggy bank safe and not pay attention to what happens. That's what countries like Panama and the Cayman Islands and other tax havens do. They have very weak regulations in terms of watching what money comes in or out of bank accounts. And they have rules that make it easy to form a corporation without disclosing who owns it. So basically, everyone gets to write a fake name on their piggy bank. There's a Panamanian law firm called Massa Fonseca.
Are you able to hear that?
Yeah.
Wow. gonna stop that there. But basically, I should emphasize this idea that you're gonna see names and all throughout this, and like they said, that can be used for legitimate purposes. But we're gonna be talking about some of the cases where through this data, they discovered that it is being used for non-so-legitimate purposes. But so the Panama Papers timeline overall is basically, they got this 10.5 million documents. And they got these documents, and some of the documents, or files actually, were relational database files. So they were relational databases that showed how all of these offshore companies that Mosaic Fonseca set up, who were the officers of these companies, where were those officers located, and things along those lines. So basically it brought light to a lot of the data that otherwise would have been pretty secret. And as you saw, it was basically an anonymous leaker, who we still don't know their name yet, reached out to Süddeutsche, sorry, I don't know how to pronounce it, SZ is the newspaper in Germany that they reached out to. And SZ was part of the International Consortium of Investigative Journalists. So the ICIJ had 3 developers, and those 3 developers got this data in the relational database form. They used an ETL tool to migrate that data over to Neo4j. Their primary reason for doing that was to visualize it in Linkurious, to basically be able to see all of the connections between the data. There's so much more that Neo4j can do, but the visualization aspect was what originally drove them to using Neo4j and Linkurious. And then they had a 1-year-long investigation by over 400 journalists around the world looking at this data and trying to understand who these connections were with and diving much deeper than what is in the raw data. There are thousands of articles that resulted in the resignation of Iceland's prime minister, resulted in the arrest of the founder of, or the founders of Mosaic Fonseca, a lot of discussions of regulation around the world, and then they actually just won the Pulitzer Prize for this work, and that was a few weeks ago. And you guys should all be proud. The ICIJ is based, their headquarters is actually based in Washington, D.C. Their headquarters is based here, and they actually just spun out as their own nonprofit and are fundraising if any of you folks are interested in seeing more of this data revealed. And as part of that, I do want to mention they actually have a lot more data than what you'll see here tonight. And there's been a lot more data that's been in raw documents, in emails, that they haven't yet parsed. And that's just for a lack of staffing to parse all of that content. But hopefully they'll get a chance to work on more of that data and produce more stories. So it was 2.6 terabytes of data. It was like 11.5 million documents, but 2.6 terabytes of data. And you can see how that compares to the size of all of the previous leaks. So they basically said, we need to use some technology to try to figure out how this data is all interconnected. They had 3 developers based out of Madrid who did all of this work. We didn't find out about it until it was basically about publishing. We helped them along kind of from that point. But it's really a lot of work that they had to put together to dive into this data. And this actually is a reminder of how technology overall has been used in leaks. So in this case, nowadays with the internet, it's super, super easy for people to leak data, as you guys see each and every day. Probably some of the people in the room are trying to prevent that. It's super easy nowadays. Back when the Pentagon Papers were leaked, this was, I think, thousands of pages of documents. They just used a photocopier. They're actually photocopying each of these things and mailing it to the press. So times have changed. It's become a lot easier to get the data, but we also need to find ways with the vast amounts of data to then interpret it. So the ICIJ has these 400 journalists around the world, and one of their their primary concern was keeping this conversation secret. They weren't worried about the likes of the NSA and things like that, and they weren't worried about that because the targets of this, none of this data was related to government or government secrets. In fact, a lot of folks in the government probably didn't want to see some of this data so they could chase down taxes. So they felt comfortable in setting up their own social network. They used a technology called Oxwall to set up an internal social network for these 400 journalists around the world to search through the documents in full text. And so a lot of this stuff is blacked out because, like I said, they didn't release all of the data. They were very responsible about what data they released. So for instance, the connections between people. They had passport numbers and copies of passports and things like that for a lot of these people. They didn't give you that in the raw database that you can download today because that would be leaking a bunch of very, very private info. But what they did end up, releasing has been screened out of that. But they did offer the journalists the option to, do full text searching on these documents. To do stuff with their own stories. But each of these journalists then didn't publish based off the raw data. They did a lot of lead work after looking at that raw data. But then they used graphs to figure out the connections between each of these things. And so this is a graph rendered in Lincurious. And Lincurious is a tool that was developed by the folks that originally created Gephi. Any of you worked with Gephi? Okay, a lot of folks. So Gephi is a visualization and a graph tool that has been used a lot in academia, but it's a little bit old school. The folks that created Gephi went on to found this company called Lincurious, which again focuses on graphs, but focuses on exposing the data on the web. And I'm going to show you some examples here. So if you go to the ICIJ's website, they have a lot of information, a lot of great videos like the ones that I showed you. And then they also have these great caricatures of a lot of the power players. And if I step over or trip over the HDMI cable, you might not be able to see this anymore. So let me not do that. But so they have these caricatures, and you can dive in for each of these people. All of these people are appearing in the Panama Papers, and the goal is to kind of understand their connections. But we're going to start out of a couple ones that we know, and we're going to show you directly in ICIJ's site and Lincurious what this looks like. And the first one we're going to show you is it is called Father of British Prime Minister. So Ian Cameron is the father of David Cameron, who at the time was the Prime Minister. And if you click on that, you then get a graph of how this person is connected. And we're going to see this in Neo4j, and there's a little bit more ability to dive deeper. Lincurious produces really awesome visualizations. Some of it is custom, a lot of it is just based off of the data that's in your database. Neo4j and its developer tools produce less awesome visualizations, will get better, but the goal really is for developers in that case. But if we look at Ian Cameron, Ian Cameron is the father of David Cameron, and we can see here that Ian Cameron had Blairmore Holdings, Inc., and we have this Bahamas Bank and Trust, which registered this company. And initially, David Cameron, the Prime Minister at the time, denied a connection to this, but later he admitted that he actually had shares in this offshore company, and he sold them right as he became Prime Minister. And basically what the accusation here is that David's father, Ian, used this to escape taxes in the UK. And so having the leader of the country trying to escape taxes to that country was quite controversial. He didn't end up having to resign, but you can look up the case of the Iceland Prime Minister, whose name I cannot pronounce at all. Thus, I am not saying his name and showing that example over and over again. But he did resign as a result of some connections. I think that was through his wife. So, these connections oftentimes weren't directly through the powerful people, but a couple levels away from them. And with Linkurious, you can see here, if you click on one of these, you can get some more data about that particular company and when it's been active and where it's located and things like that. And we'll show the data inside the graph database as well. So what I'm looking at here is the Neo4j Sandbox. So neo4j.com/sandbox. And what it is a free sort of online service to allow you to try out the enterprise version of Neo4j using some interesting data sets. And so the top two here are very businessy data sets, recommendation engines, and network management. But then we get some ones that are a little bit more interesting on a personal basis. You can look at your own Twitter network. If you sign in with your Twitter account, you can look at the graph of your Twitter, your tweets and your followers and people you're following. It doesn't go out many levels because of API quotas, but I encourage you to try that out. Legisgraph, which is a graph of the legislation passed by Congress and all the votes and the representatives and things like that. Trump World, which we may open up here if we have time, but that's actually kind of similar type of graph to some of the Panama Papers stuff, in that it's basically trying to show the connections between different people that were nominated and are now confirmed for positions in Trump's cabinet. And it's really fun when you overlay that data on top of the government contracting data to see the relationships between the cabinet members and the government contracts that then their particular areas of government actually then control. And it becomes this pretty interesting circle there. But anyway, I encourage you to check this out. You can get started with Neo4j literally by clicking on that button. In about 30 seconds, you have a Neo4j Sandbox. I'm going to go through the Panama Papers one here because that's the topic of the talk. But I encourage you to go through the others. Each of them has a data set and then guides. The Panama Papers, the ICIJ folks wrote probably the nicest looking guide that exists amongst all of these. The rest of these were written by engineers, but they actually had some designers that went and wrote their guides. So I encourage you to explore through it. Our goal here with these guides, and ICIJ's goal, is to really teach you how to understand the graph and use that graph to then explore the data. So it explains the nodes, for instance, in the graph. Nodes are sort of your nouns or basically your objects. It explains relationships, which are your verbs, and then it explains all the properties and how those work. But I'm going to go in and give you a couple of demos here while zooming in as much as I can on this display. The first thing I'm going to show you here is we're going to do a simple procedure call. We're going to call the APOC meta graph procedure. With Neo4j, it's a graph database. Your data is stored in these nodes and relationships, but you can write functions and procedures in Java that then execute in addition to writing these queries. So this is the procedure that is getting a meta graph. Basically, I'm trying to see what all is in this Panama Papers graph. So we see 4 different nodes here. I realize you might not see the screen at the back, so feel free to step forward, or I'm explaining it a little bit here. The top thing is the intermediary nodes. And these intermediaries are basically the organizations which were used to set up the offshore entities. And then we have officers of each of these organizations, and then we have addresses. So it's a very simplified graph from that raw data set, again, to kind of avoid revealing too much information. And they initially published only a handful of types of relationships between each of these different entities. But then they went on to all of those little lines that you see there in that gray design here are different types of relationships between each of these entities and intermediaries and officers. And that was so they could be very, very specific. So no one would call them up and say, well, you said I'm a member of this group. I'm not a member, I'm an advisor, or things like that. They had to be super, super specific because this data was in the end being used to get people to resign from their powerful positions. So you can run that, you can see all these different types of relationships. There's things like attorney, in fact, vice president, secretary, president or VP, treasurer, director, that sort of thing. So let me actually show you, start with a relatively easy query here. So this query language is called Cypher, which is a declarative query language similar to SQL, but for graphs. And the idea behind this query language is that you can search graphs how they're designed. And so graphs are representing connections between various objects. And in this case here, we're basically saying, find me an intermediary which it has a relationship of intermediary of an entity. Not that complex of relationships in this graph, and we're looking for where that intermediary's name is Mossack, which is the Mossack Fonseca law firm that exposed this data. And the jurisdiction is SEY, which is the Seychelles Islands. And if you run that, you get this graph. And so this is basically saying, here are all the, I think we actually limited the number of returns here, but here are the companies that were set up to by Mossack Fonseca in the Seychelles. And then for any of these, we can go and double click on one of these nodes and start navigating the graph. So we have this company called Heptacore, which is an intermediary, Mossack Fonseca is an intermediary for this company called Heptacore, and then we have a person named Lim Chong Moon, who is a shareholder of that company, and then we can double click on him and we can say, oh, he's also a shareholder of the Wealth Harvest family in a Sage Corp Ltd. And then you can say, oh, where does he live? He lives at 115 Greenfield Drive in Singapore. And so you can keep on kind of navigating the graph, and essentially that's what a lot of the journalists did. And these 400 journalists around the world, obviously located in various places, a lot of them focused geographically. A lot of them focused on, find me the people in my country that have bank accounts in the Seychelles, or have these offshore companies registered in the Seychelles, or similar. So we'll see how that actually works if we wanted to do something like that, if the journalists might do. Now, many of the journalists just navigated through the graph like you saw earlier with Link Curious, whereas other of the journalists did actually write these Cypher queries in order to navigate the graph. But I'm going to show all of these example queries, but I'm going to shift my order around a little bit. And in this case here, what I'm going to do is say, I want to find addresses. So I want to find officers of companies who have registered addresses, and that officer has a relationship to an entity, which is an intermediary of an intermediary. And then I'm going to look for where that officer's address is in Arlington, and in particular Arlington, Virginia. Anyone here live in Arlington whose name appears in the Panama Papers? Someone? Okay, one person. Again, to re-emphasize, since I'm running this on real people's names that you might know, is these people could just be trying to have some privacy. They might not be evading taxes. etc. You can ask them. So we're gonna run this query here, and basically we're gonna say, I want to find the jurisdiction and the number, and this is a very basic query, and we can return more information. Right now, I'm just going to return this. I will return the actual nodes and relationships, as long as you understand that warning. The British Virgin Islands, Cayman Islands, Samoa, and Cook Islands. So it appears that there's no real winner. If you're a person that is an officer of a company in Arlington, you have a number of different offshore jurisdictions to choose from that are equally as popular. And let me show you which actually returns the graph. Okay, here's the actual graph with my warning still. So we have an address here of 1317 North 14th Street, and there's an officer here, and I'm not going to bother saying the names because A, I can't pronounce some of them, and B, I don't want to call them out that badly. But and then we have Mark here and Scott Street. Here's one that kind of returned the most interesting thing here. We have a officer, which is the person's full name, who has registered an intermediary, which is named their full name. This person likely is not using it to evade taxes because they'd be really dumb if they named their offshore company by their name in order to avoid taxes. But it is an intermediary of this other company, Zodiac Concepts, and all of them have this registered address. So the person has an address in Arlington, this Zodiac Companies or Concepts has an address in Arlington, and then there's another additional address that is used. Actually, these just weren't deduped. So the problem with this massive amount of data is that you don't always dedupe things. These are exactly the same address, so they should be pointing to the same node. But you can go through and see this, and you can see this address and these people, double-click and see more information. And this actually gets even more interesting with this person, is there's another intermediary of, and then another person who's a beneficiary of that. So the question is how many of these actually interconnect to our friends here in Arlington? But you guys can explore that yourself. But that's the type of value that a graph provides, is basically the ability to really understand the data as the data was designed. If you try to represent this in rows and columns, it would not be nearly as easy to explore. Visually, it's also not nearly as efficient to explore it programmatically in that form when it's a lot of different relationship paths that you're following. And to get ourselves out of the Arlington folks, let's look at someone a little bit more famous. This is the Ian Cameron, the father of David Cameron that I talked about, and representing the same graph kind of inside the Neo4j tool that we did in the Curious. And so Ian Cameron is this director of this Larmark or something. And there's an intermediary, which is this Bahamas company. And then you can look at what are all the other companies that this Bahamas trust company has set up. And then try to see what are the relationships between them and go back to Ian Cameron. And I'm doing this by click, 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 and that sort of thing. The idea behind these Cypher queries here is that you can write queries that do this for you and find this a little bit faster. But a lot of the journalists were actually kind of doing the click and navigate approach when they weren't familiar with Cypher. Here's a query that shows you the power of this language a little bit more. And what we're trying to do here is actually find, I'm not going to go through line by line, but basically what we're trying to find here is two different officers, two different people who have common connections to entities, and how many common connections they have. So what are the common pairs of officers in a business?
I'm going to interrupt just quickly, because this is so detailed. If anybody has questions,
We always like interactive sessions, so just raise your hand and we'll make sure you get heard. Okay, thanks.
Any questions? Yes.
So, I missed it. Can you stand up? Is this available to the public as is, or do you have to pay?
Yeah, no, this is available to the public as is. There's 2 ways you can get it, or 3 ways actually. You can go to neo4j.com/sandbox and then just try it out kind of on our computers. We're paying for the EC2 instances for you to try it out. And you can also go to offshoreleaks.icij.org. And from there you can download either just the raw data, or you can download actually a Neo4j installation that they distribute that includes all of the data in Neo4j. So you want the raw data, you throw in some other tool and analyze it, or you can download the Neo4j from there. But the easiest probably is the sandbox. Yes?
So, the pre-processing and extraction of this
You're near the front,
the pre-processing and extraction of this relationships is all done through natural language processing, obviously, if I'm not wrong. So, is it part of Neo4j package as well, or?
Sure, so it actually, this isn't done through natural language processing. A lot of people do natural language processing with Neo4j. In this case, this is a relational database that was among that 11.5 million files that they got. It was actually a SQL Server database that was running inside the company. And that database, they used an ETL tool to convert the tables, columns, rows into a graph form. Okay. Sorry, I'm getting over a cold here, so I apologize as I keep losing my voice, but I'll just move the microphone closer and closer. Hopefully you don't get distracted by my talk. Actually, so the common officers pairs, we didn't actually run that. But the goal here is to navigate the graph and find the officers that appear as officers together a lot within the graph. Yes?
So, is there a way that...
Stand up, make your voice.
Say loud.
Scared.
So, is there a way that this tool could also consider when you build a relationship, says when you terminate it, because it was my previous boss did that, I didn't do it.
Yeah, so the question is basically, would this tool in any way consider the date of the relationship or when these things happen as you navigate the graph? They didn't in the ICIJ, they didn't in the raw data. Like I said, every time they found something that looked interesting, they then dove a lot deeper into it with real, they went to the courthouses, they went to the various records. But this data did not indicate things other than sort of like the raw dates of when the account was created, I believe. What people do in general is they'll have on the relationships, like let's say this company is an intermediary of this company. On that relationship, you can actually indicate properties. So you can say that relationship started at a particular time and ended at a particular time. And then as you traverse the graph, you can restrict the traversals based off of a particular time. So you want to look at all the companies that existed in 2016. You could do that sort of traversal. And it would just skip the relationships which are outside of those bounds. So here's the result here of querying the common officer pairs. So let me see if I can zoom in. Okay, so we have basically, we list 2 different officers, officer name 1 and officer name 2. And they appeared together, in this case, 540 times. These 2 officers appeared together. And in this case, Alfred Novak and Belvedere Corporation, 432. And what's interesting about some of this is if you read on the case of Ian Cameron, David Cameron's father, he actually used random citizens of, as Aruba or something like that, random citizens in in the town, or on the country that their accounts were set up in order to have shareholders, or not shareholders, but officers of the company. They would basically recruit people to, on the island to set these things up. So I don't know if any of these were those sort of people where they just went around and set up a bunch of different companies, or if any of these are purely legitimate. Some of these are names, some of these are companies who are officers of other companies. And like I said, you're seeing some things here. The data, isn't the cleanest data in the world. It's not always going to be, so you might see some cases where it doesn't look quite right. Dive into that further. Yes.
Elliot, I know you project your voice.
So have any academic studies or models been done on this data set to just try to find any kind of relationships that would be so obvious if it was transversed by hand?
I don't know of any. I would love it if you found some. The ICIJ has lists of hundreds of articles that have been written, but those are mostly, news articles. This has been out about a year. It was April of 2016, so it might have been a little bit too fast now for the academic studies to be done, but I'd definitely be curious if anyone does that. What would be interesting too is if in the academic studies, if they could get a hold of some of the more of the data. So for instance, the emails, and look at how the emails relate to these accounts setting up. So they have email, basically every email that Mosaic Fonseca ever sent, I think. But they haven't been able to release that data because they haven't been able to go through it. So along those lines, is we actually did, as Neo4j, we actually are sponsoring a fellowship. The deadline just passed, but the fellowship is for a data journalist to work at the ICIJ on connected data. And we have no say over what work they do. We leave that to their journalistic standards. But we're basically sponsoring that fellowship so that folks, basically where we agreed on the criteria is it's basically post-grad folks or folks that are early in their careers can go and work at the ICIJ, and then they'll have more access to this type of data. So that could be something that fellow ends up doing depending on what their relationship is to the journalist schools or to the other organizations.
Pause. Here's the tea. Here you go.
Thank you. Tea. Or at least steam. But thank you. Steam is actually really good. It smells good. Okay, so this is kind of the relationship where there's multiple officers that have that share connections, and then I will go in here and say shortest paths is one of those types of algorithms that you might run. In this case, I'm doing very generic. Find me the shortest paths between officers whose name contains Smith and officers whose names contain Grant, and the shortest paths of certain types of relationships. And if we look here, we basically find an Ian Stewart Grant, and we have the paths then to sorry, this is finding all shortest paths. So there's multiple here, but we have Ian Stewart Grant, and then down here is Stuart Onslaw Smith. And so we can see if you wanted to get from this Grant to this Smith, basically you can see that this Grant is a director of an organization which has the same registered address as this Smith is a director of an organization which has that registered address. So you're trying to see, like, is there a relationship between these people or these organizations, and you can use kind of graph algorithms here, a very simple shortest path algorithm, in order to see what those relationships look like. Okay. So here is a little bit more advanced algorithm. PageRank, which was the algorithm created by Google that basically says, as you traverse the web, if a page links to another page, that page passes on some of its rank, some of its score to that other page, and it keeps on going in that chain. You can use PageRank to see what the influence is between people as well. And so what this is trying to say is, what are the entities or intermediaries in the Panama Papers that have the most relationship to other companies. And we see Austro Bank overseas in Panama, and these are scores for their PageRanks. And so then you can start going down through that sort of from top to bottom to try to find out, how are those networks formed between those people. And what's more interesting is when you take a PageRank and actually rank addresses in this case. So what are the registered addresses for the various corporations and officers, and how are those page ranked? So apparently this Portcullis Trustnet Chambers in Tortola, British Virgin Islands is sort of the most influential address. It's the address that has the most connections to these companies, direct and indirect. And you go down through the list here too. So these, in theory, are kind of being the most powerful of these intermediary addresses. And I'm guessing if you go, well, I guess this is explicitly a PO box. If you go to many of these, I'm guessing there might be one administrative assistant, but not much else. So that's kind of it for these queries. To give you a general idea here, we talked about our nodes, which are the nouns, the various entities. We talked about the relationships, intermediary of, or registered address. We talked a little bit about Cypher, which is the query language that you can use to query the graph. And we showed you some graph algorithms that you can run on this type of data. And you can also run it on that Trump world graph and some other graphs to see some great things about how all this interconnects. This is the Neo4j browser, is the tool that I've been using to navigate through the graph. This is the developer tool that comes with Neo4j. Neo4j is available completely for free, open source in the community edition. Many use cases for this type of analysis, that works totally fine. There's an enterprise edition as well that offers kind of the HA and or high availability and clustering features and more administrative features. But if you visit the Neo4j Sandbox, you can run a lot of these queries yourself, including these algorithms. They're all available, including many more that I demonstrate on here. Reach out to me at brian@neo4j.com if you have anything that you want to learn about. We do have this data journalism accelerator program for either if there's any journalists in this audience, or you have friends who are journalists. Basically what this is just send us a note, and we'll work with you to get your data into Neo4j and help you work with your data and understand that data as a graph. With the only agreement is if you publish articles based off of that you just mentioned that you use Neo4j. And so we're happy to work with data journalists. We are working with, we don't have any published articles out of this yet, but we are working with pretty much all the top media publications right now, either doing workshops or doing, actually one-on-one help with their journalists. And a reminder, that is the Graph Connect code. And now I'll take some additional questions. If there are any questions, I'm happy to take.
First. I have.
Sure, you get the mic.
I'm curious about, we went through a lot of the queries and how you can explore the network, and we showed that there were some people that were connected to multiple, and there was a lot of coincidental names, and you explained the process by which other journalists explored this information and how to use the tool in order to do that. And I think it's going to be, if anybody goes out and does this and finds interesting things, or we just want to have a hack around this, like we've been doing those mini hacks, maybe this is a good topic for that. But now there's the follow-on, which is, what are the insights?
Sure, I tried to kind of start off with some of the impacts from it, but you know, overall, this is kind of a starting point for the analysis. And what happened as a result of that, the Iceland Prime Minister resigned, Ian Cameron, actually one of his advisors just came out to say that he thought he was going to have to resign, but never did. You know, the insights really just come down to what the connections are between each of these entities, and more are found every day. There are articles about the Panama Papers data set, like last week. There's been testimony in Parliament, testimony of the European Union. So, you know, basically the insights are in the real world, not just in the data, but the data help those be discovered, right? And make it easier for these journalists to discover these things. And then, you know, in the past, when you have these treasure troves of data, is oftentimes they just kind of sat on the shelf, like those emails, for instance. The emails are still sitting on the shelf because they don't have the tools to analyze them as easily. But so there's no great insights into the actual data beyond the conclusions of the arrests of the founders of Mosaic Fonseca, or the resignation of these various folks. But you know, I think that I'd love to see them go back through and clean up the data. The problem is that just takes too much work for a nonprofit to do. They're raising money, but so I'd love to go back through and say, you know, here are the real connections, and dedupe all those names, and dedupe the addresses, and you know, a lot of work could be done there. But like I said, there's private data that's involved there that they could actually publish. So it would be very difficult to do that off of the data that they publish.
I guess building off that question, is there a statute of limitations that would basically put, like, the longer the data sets on the shelf, the less prosecutorial evidence countries will have to actually go after these people?
I'm just going to say I'm not a lawyer, but we're also talking about 100+ jurisdictions, right? Like all of these different countries all around the world. So I'm sure that varies country to country. But what's happening as a result of it in many countries is legislation is being passed that makes this more difficult. Makes it more difficult to create these offshore accounts and such. The question was, is statistical analysis available within Neo4j? So minimal sort of aggregation functions are there. So min, max, means, that sort of thing. There's standard deviation. You can write any of these stored procedures in Java to do any other type of analysis. Oftentimes what people are doing when they're doing statistical analysis off of this data is taking a subgraph, and they're doing statistical analysis off that subgraph. In that case, you know, there's a driver for R that allows you to pull the Neo4j data into R and do statistical analysis within R. And there are drivers for other statistical platforms. So I showed you kind of using the web interface. The primary way that people interact with Neo4j is through programming languages, such as R or Java or Python or .NET, JavaScript, etc. But those are kind of the two ways. There are definitely a lot of people that do use it, you know, with statistics. But most of that, I think, is done outside of Neo4j with the raw data set in Neo.
Thanks for the presentation. Am I correct in sort of assuming that it was a huge break to have the relational database there, rather than just a bunch of raw documents that would have had to be ETL? And then this follow-up question to that is, given that they already had structured data, relational database, did they then have to sort of hand tool in the relations to create the lines between the nodes?
So, yes, I mean, it was a gold mine that they had this relational database, right? So, you know, that's what they initially published. If they just had the other data, it probably would have taken them a lot longer. They only had these 3 developers in Spain working on this. and they hadn't dealt with this size of data before. I think nowadays with character recognition and some of the search functionality, even some of the tools that they used, they threw the PDFs and other content for the journalists to use. But they kind of started, a lot of the journalists started at the graph, then found the names or found whatever, and then searched the raw documents for that. There are projects, the OCCRP, the Organized Crime and Corruption Reporting Project based out of Berlin, actually has a tool that they built where journalists can upload documents and it does entity discovery within those documents. So it looks and says, this is a company name, this is a person name, this is a country, this is a city, etc., and does create the graph out of all of those raw documents to link them together. And so they do a lot of stuff with Neo4j in creating this repository for a lot of journalists to use. So yes, I mean, basically it was a gold mine. If they didn't have that, it would have taken more work. But hopefully we would still see the end result. They would have just had to spend more resources on it. Hopefully they would have had that. And then, yeah, the second part is kind of how the relationships were named from the original structured database. And I think that their relationships are named based off of tables in the database. Is often how it is, the tables and the foreign key relationships in the tables. But I never saw the raw database. The raw database they've kept pretty undercover. In the back.
Well, I can talk pretty loud. Just have a conversation, man.
There we go. Especially now that there are a lot of issues, of course, being called out by certain political figures about the lying media, do you think that there's going to be a greater push to actually have more data? I know that there's some journalists, say like Mike Bostock, who actually did a lot of work with D3JS. Is there going to be greater adoption? Have you seen any greater adoption by journalists that going out and doing more data visualization of this? Or data sets that are available to show?
Yeah, so Mike's work is fantastic. D3 is what a lot of these tools are based on, including the Neo4j browser uses D3. New York Times and other folks have started to venture into a lot more graphics and even graphs as graphics for these things. I feel a little like I'm talking to you and talking to the camera over here. But anyway, so there are organizations that are starting to get more and more involved in using visualizations and using graphs as tools to generate those visualizations. Every single wire service and probably top 10 newspapers in the US we are working with on kind of that data journalism accelerator program. And so I can see that there's a lot of interest, but it's a matter of kind of bringing the media organizations' data and technology skills up. So even the ICIJ is, the primary person that we worked with is Mark Cabra at ICIJ. She's not really a data journalist, she's an investigative journalist. Background is purely journalist. They need help with people that understand data. And so that's probably the limiting factor, is just getting people that understand data, helping them out. So I encourage you all to do that. But yeah, I mean, to your other part of that, I might just have a more cynical view that data is no longer meaningful to a lot of people for some reason. And so even if we show data, people continue to believe what they believe, but unfortunately. All right, sorry, there's one other question in the back. Oh, sorry.
First, thank you so much. This has been fascinating. Thank you for sharing this world with us. I just have a historical point to note. The interesting thing for me about the Iceland example is that after, I think his name was Bjorn Pedersen or something, the Prime Minister had to resign, the voters had a backlash against the mainstream political parties in Iceland as a result, and they elected as their next Prime Minister a woman whose name I'm also going to murder, but it was something like the Regatta Beyond Flotilla. And she was the head of something called the Pirate Party, which is an alternative fringe party that believes in bringing technology to the power of people. And her promise to the Iceland people is to use technology to take democracy to them. They are going to be able to vote on their own nation's budget as individuals from their terminal, according to her. So I think it's just an interesting historical irony that the technology that brought down the previous generation of politicians may in fact spawn a whole new democratic model.
Thank you very much for the insight. And interestingly, like if you search actually for Panama Papers right now, there was just another election where the politician was tainted by the Panama Papers but still won the election. So you can also beat someone up the day before an election and still win. Anything else? Yes.
Data on magnitude, and can you show it on Neo4j, like larger, thicker edges or larger nodes or something?
Yeah, so I mean, Neo4j itself is not meant to be a data visualization tool directly. Like it has the visualization component in the developer framework, but you're going to use something like Curious or one of the other like BI tools if you're doing this just for business people. There are people that have built graphs like that. I think even Mike Bostock, the name that was mentioned, has some examples. We do other graphs that are have icons as in the nodes based off of the type of the nodes. You can look at our developers, neo4j.com/developer or something to see that example. But so there's all sorts of things that you can do actually with the graphs to convey information. The basic Neo4j functionality there just does different colors based off of types. You can change the line weights based off of the relationship. But we don't yet do things like, one of the things we really want to see done is automatic clustering of the various nodes so that you have progressive levels of detail. If you zoom in, you see more and more nodes come up out of the cluster. If you zoom out, they become one cluster. And it's just trying to figure out kind of the algorithms for doing that with a generic set of data, right? So it's much easier, some of our customers do that around things like fraud, but they know exactly what their data is, whereas we have to build it within our tooling based off of any type of data in the world that could go into the database. So that's kind of the line. Right now, we basically say, customers build that, use that, and I'd say probably, I don't know, I can't imagine probably more than 30% of our customers actually use the graph visualizations as part of their process. They're really using graphs because of the way that it represents the relationships and the performance of doing queries on those relationships. But their actual representation of the data at the end is tabular, is search results, or is other things. But
I have one more question. I don't know if you're but I tried to use Neo4j a few years ago. I ran into some speed issues. Is there a way that you can characterize trying to use Neo4j to power a web application or live data visualization with, can you quickly characterize, depending on the amount of data, the interconnectedness of the data, the type of algorithm that you're using to do, because these queries are almost like small algorithms in a way, right? The type of, the sophistication of the query, how do those play into the speed, maybe the type of data that's underlying it, how do that play into the speed to power a web application?
Sure, so how many of you are computer scientists in the audience? Okay, we have 20%. What's that?
I was just wondering if
physics counts? Sure. So, I mean, I don't know. It used to be math. You never had a degree in computer science, you had a degree in math. So, physics is more math than I ever wanted to take, for sure. But anyway, so the way that the traversal works in Neo4j is essentially like pointer arithmetic. So as you traverse from one node to another node in the graph, what you're doing is saying advance 34 bytes. Advance another 34 bytes. Oftentimes it's in memory. We rely upon memory heavily to cache the data. So that traversal then becomes very fast in memory. If that is on disk, it's slower. If you have to pull it off of memory, you can't just do the very simple pointer arithmetic. But the general idea is that Neo4j, we use the word internet scale. We power things like Walmart. We power things, other top e-commerce sites that I can't mention, eBay's delivery service. We power a lot of applications, but you do have to do some tuning, like anything. So, and it could also be, we've done a lot of performance improvements over the last few years since you tried it out. The general idea is our customers usually are a few billion nodes or less, although we go up to, we used to have a limit at 34 billion nodes in relationships. We got rid of that. You can go higher. We do have clusters for the idea of failover and for operational concerns, for the idea of taking your queries and spreading them across a bunch of different servers from a read perspective. The graph is still copied to each member of the cluster. So from a write perspective, you're balancing reads over writes is what you're doing when you build a graph. But that's what our customers are looking for. There's very few people that have performance concerns that we haven't been able to work out, but sometimes it does take some highly tuned queries, and sometimes it does take even diving into Java and traversing based off of what the structure is of the graph. Cypher is meant, the query language is meant to find things really easily, write the queries very easily, but it's us deciding then how to optimize those queries. And anytime the computer is deciding, the computer could end up deciding a slightly different path than it should take. And so we have engineers that work very closely with the customers to optimize when they need that. So airline scheduling systems and things like that are based off of Neo. But anyway, so yeah, I don't think, in the real world, we don't have performance concerns. Some of the things that people try to do initially when first learning, there is that sort of barrier at times, because you're still trying to understand what is the structure of the underlying data, and what traversals are happening, and where to put indexes. So we do use indexes when you kind of find the start points of the traversal of the graph, but most graph queries are only then going to traverse subgraphs. They're not going to traverse the whole graph. And it's the same thing like a full table scan in a relational database. If you do a full table scan or a full graph scan in Neo4j, that's going to be expensive, at least the first time around. Low battery. For all of us, low battery.
My computer's running out. Round of applause. Since my computer is now dead, we're going to be going over to Highline. If you like beer or drinks, they have other food if this wasn't enough for you. I will lead the first wave. Corinne, you will lead the second wave. And Dan, are you still there?
Yes.
If you need anything from anybody here, just ask. But I want to thank you again for letting us use your space and for helping clean up and everything.
Thanks for coming.
Thank you all for coming.